In this demonstration, you'll use balls of clay to explore how stars fuse elements inside their cores. Each different color represents a different element. Here, pink represents hydrogen, blue is helium, purple is carbon, orange is oxygen, and this tennis ball is neon. We'll start with hydrogen, just like you've got in the center of a young star. The inside of a star is hot and dense, and all of these hydrogen atoms keep bumping together. Often, some of them will stick together. This is called fusion. So we squish together 4 pink balls representing hydrogen, and these form a new element, helium, represented by the blue clay. The sun's been doing this for nearly 5 billion years. Eventually, the hydrogen in the center of the star runs low, and we've mostly got a lot of helium jostling together instead. When hydrogen fusion stops, the star is no longer in equilibrium, and the core shrinks down. But this makes things even hotter, so the star can start to fuse helium into carbon. So we squish together 3 blue helium atoms to make 1 purple carbon atom. In the sun, this is where things will end once the helium runs low. But if a star is much bigger than the sun, the core will shrink again, and it'll get even hotter at the center. Now the star can fuse together a carbon and a helium atom, creating oxygen. So we'll squish a blue helium atom and a purple carbon atom, and that turns into 1 orange oxygen atom. You can imagine what happens when carbon runs low and fusion stops once more. The core shrinks, things get hotter, and new fusion can begin again. Helium and oxygen start to fuse into neon. So we squish a blue helium atom and an orange oxygen atom, and swap that out for a tennis ball that represents neon. Depending on the size of the star, this process can continue through the periodic table up to the point where iron is formed. But to fuse iron, you need to input energy. With energy going into fusion instead of coming out of it, the star can never be in equilibrium again, and its days are numbered.